Hey everyone, this is Ms. Rodriguez, and I'm doing the screencast for Human Impact on Ecosystems, which in this marine science class will focus mainly on marine ecosystems. So, with human population growth and natural resources, everything that humans use comes from the earth. Okay, we don't just make it out of thin air, everything has to come, some component has to come from the earth. So, we are completely dependent on this planet that we live on. And Earth has a carrying capacity, and a carrying capacity is pretty much kind of like an occupation capacity inside of a restaurant. You can't put 500 people in a restaurant that can only fit 50. It's the same concept with Earth. We have the same limitation, we just don't know the true number of how many people can actually exist here, but we keep pushing that limit every single year. It can't have an infinite number of people just because we don't have enough resources to sustain that many people. Eventually, we will run out of resources and we won't be able to reproduce them fast enough to keep up with our needs. So the majority of our energy use comes from oil and coal. Oil and coal are made up of dead organisms that over millions of years have formed into concentrated carbon that form into that oil and coal. These are known as non-renewable resources, mainly because they are used faster than they can be formed. So what do you think will happen if we run out of non-renewable resources? Well, we can't use those anymore, so we would be forced to come up with an alternative version of fuel or energy to power the things that we're so used to having. Your cell phone battery, all that stuff. I mean, it gets charged through electricity that you find in the wall, but that electricity is being powered by something else. In most cases, it's the fossil fuels. So non-renewable marine resources are petroleum, which is oil, and natural gas. So 1/3 of the world's oil comes from offshore drilling sites that are found deep in the sand in spaces that are between rock. Over millions of years, as plankton have died, their bodies undergo the conversion into both petroleum, oil, and natural gas. Now, how could oil drilling be dangerous? Well, we saw a few years ago with BP drilling off the shore of Louisiana and in the Gulf of Mexico that it's very easy for something to go wrong. Okay, they had an oil spill which led to the pollution, and that in turn ended up affecting the economy of the Gulf Coast areas, but on top of that, you were disrupting marine life that were living there. Everything that happens in an oil spill doesn't just affect the company that made the oil spill, it's going to affect everything. And oil is very hard to clean up and to get rid of. That's why it took so long for the Gulf Coast to be able to actually have tourism come back to them, because there was so much damage that no one was going to spend money to go out there and go to beaches that were filled with oil. The oil spill happened out in the middle of the Gulf of Mexico, and just because of currents in the ocean, ended up on beaches, and then you saw animals that were dying or were covered in slicks of oil that were showing up on beaches, and there was nothing we could do about it. So that is one way that human impact has affected the non-renewable marine resource. Another non-renewable marine resource is salt and minerals. Salt is used for food, medicine, and melting ice. Okay, you guys might hear that taking in sea salt is much better than taking in regular table salt. So we are taking salt from out of the ocean to use in our food. Salt is extracted through the evaporation of water. So when they have the capabilities to, they have these water pads, and then they pretty much put enough heat on it to evaporate the water, and the salt stays behind on a screen, and then they can come in and collect the salt. You also have magnesium that comes from out of the ocean, and magnesium is used to make a lightweight metal, which is what we use to make our jet aircrafts. Magnesium is extracted from seawater using electrical and chemical processes. We don't have to get into detail as to how those processes work, but that is how we do pull magnesium from out of the ocean water to eventually give us the fighter jets that we have in our military armory. Now we have renewable resources, which are resources that can be replenished by natural processes within a lifetime. So with marine science, the biggest one obviously is the ocean. Okay, wave energy. There are constantly waves, whether we see them or not, whether it's a flat day and we see traces, or it's a good day and we're seeing 6 to 8 foot waves. Wave energy is something that's always going to be around as long as the oceans exist. And then fish stocks, like fish will always reproduce. Now there's a caveat to that, because if we go and overfish and we are taking all of the fish prior to where they can reproduce, then the numbers are going to greatly decline, and it is possible that you could make them go extinct, and then in that case you wouldn't have that fish anymore. So fish stocks is a caveat. It's renewable as long as we allow it to be renewable. Other forms of renewable energy are wind, solar power, biomass, geothermal energy, hydropower. Alright, so going into wave energy, you have a caisson, which is a chamber filled with compressed air that creates wave energy. And the rising waves compress air into the chamber, forcing it through a turbine that spins to generate electricity. So this is one way that island nations could use water and waves as a form of energy instead of relying solely on non-renewable resources. With marine mammals, in respect to marine mammals, whaling for the blubber, which is their fat, was made into oil, and that's been around for at least a couple thousand years. That used to be the only way that you could put a lamp on at night, was through oil that you got from the blubber of whales. So whaling now has been set with limitations, and there's some places where you cannot at all hunt these animals. So if you see here in 1946, the International Whaling Commission, or the IWC, set limitations because whale populations were diminishing. We were taking out whales faster than we could allow them to reproduce. In 1972, the U.S. Marine Mammals Protection Act prohibits the hunting of any marine mammal, but not all of the countries follow this, because if they did, we would not have documentaries like The Cove, which exploit Japan's use of luring dolphins into a cove and murdering them for sport. So that clearly goes against the U.S. Marine Mammals Protection Act, which was developed in 1972. Now again, with fish, we brought up fish and how they're a renewable resource, but they have a caveat to it. And that's because of overfishing. So overfishing occurs when more fish are caught than the population can replace naturally. Right, that makes sense. The laws in place on which species you can catch and how much, they have those out there, so then that way you cannot solely go after one specific type of fish. Just like down here in Florida, we have lobster season and mini lobster season. You can only have so many of them. If you get caught with more, then you're fined, and I don't believe you can get arrested, but you are fined for going in excess of what the law says you can have. Marine protected areas where fishing is banned. There are certain places in the world where you are not allowed to fish. You get caught fishing there, and you have a very, very hefty fine, if not jail time. And it's not just in the United States. This is all over the world. So if you can see here in the diagram, by 2050 is the year some experts say the world fisheries will collapse because of overfishing. And $50 billion is lost every year from mismanaged fisheries, and that's because they're not using all the resources, or the way that they acquire their fish actually ends up costing them more money, and in the long run. 90% of predatory fish like tuna, sharks, swordfish, cod, and halibut are gone because of the fact that we've cut down our food supply, or we're hunting them and we're fishing. We're hunting them for different reasons, whether it's shark fin soup or necklaces or shark cartilage, or just all the different types of tuna and different types of swordfish. People are overfishing those, and we're losing them faster than they can replace themselves. 300,000 whales and dolphins are killed each year by getting stuck in the sea nets when they're actually trying to catch other fish. 57% of the world's fish stocks are already fully exploited, and less than 2% of the world's oceans are actually being protected. That's a very, very, very small amount when you consider that the Earth is 70% water. So 2%, less than 2% is a very, very small amount. It takes a whole effort, a global effort, to make sure that overfishing and the destruction of the marine ecosystem doesn't take place. We have aquaculturing, which is water farming of organisms like fish, oysters, and algae. So growing fish in a contained environment will help fisheries with their overfishing. And they're trying to figure out, can it be a facility or in the water? So that's the difference when you go to the supermarket and you hear, farmed fish versus fresh fish. Fresh fish was caught out on a boat. Farmed fish were products of aquaculture. So having these water farms actually helps because they can control the amount of fish that are being bred and the amount of fish that they can sell and reproduce, and they can keep track of those numbers so that way they don't run out. We have algae, which is another common organism that's grown in aquaculture for food and medicinal uses. So with algae, we use it for biofuel. We use it for agar, and if you ever take a microbiology class, agar is that special gel that's inside of the petri dish, which we run a lot of experiments on to figure out whether or not certain medications work with certain new types of bacteria or viruses. Algae is used as fertilizer. Algae is a part of vitamins. Algae is a portion of pigments and is also a part of pollution control. The ultimate biological resource that we have is biodiversity. So biological diversity, which is also biodiversity, is the total of all the genetically based variation in all organisms in the biosphere. Biodiversity is one of the Earth's greatest natural resources by contributing to medicine and ecosystem goods and services. So remember, if one organism is removed from the ocean food chain, the entire ecosystem can collapse. So that's one of those things where people are always saying, oh, well, you can just get rid of sharks and you can get rid of, any of those animals in the marine environment that'll attack you. And the thing is, you really can't, because as soon as you take one of them out, you end up with a pyramid of problems that will take place later. So you cannot take out the top dog in the food chain and think that everything's going to be okay, because then you have overpopulation, and overpopulation is also a problem. Not just not having enough, but having too many can cause detrimental effects, not only to the marine ecosystem, but when you affect one ecosystem, it'll go ahead and transfer over to other ecosystems, in this case terrestrial ecosystems or earth-based ecosystems, that'll affect humans directly. Now, the amount of land that's needed to produce and maintain enough food, water, shelter, energy, and waste is called an ecological footprint. And this translates into a marine science sense only because normally the country that has a larger ecological footprint needs to find a way to get rid of the waste. And so they're the ones who are doing the most pollution and the most damage to our water supply and our air supply, which all affects our marine ecosystem. So each country has a different size ecological footprint. Most countries who are very well developed will have a very large ecological footprint. Waste management will start to become important as well, because if we can't manage our wastes, then we're going to end up in a situation very much like the movie WALL-E, where the planet is covered in waste, the ocean is covered in waste, and it's no longer inhabitable for human beings. As you can see, air quality is a big thing. Each year, humans add synthetic chemicals and materials to the earth, and this is what we call our pollution. Pollution is described as any undesirable factor or pollutant that is added to the air, water, or soil. And the most common air pollution comes from the burning of fossil fuels. And again, we get our fossil fuels from out of the ocean through the oil drilling. So this is going to conclude the first part of our human impact series of screencasts. There will be a link to another screencast where we will kick off with air quality and then continue on.